Okay, let's work an example now where I am subtracting, in this case, two rational expressions, and they have different denominators. Remember, we're going to borrow the technique from when we work with just regular old fractions. So the method looks something like this. First thing we do is we're going to determine the least common denominator. Okay, remember that means to find the common factors between the two denominators. The second thing is to rewrite each expression as an equivalent fraction, as an equivalent rational expression with the LCD. Okay, next we actually do the add subtract. And remember what that means is that by now we have two rational expressions. They both have the same common denominator, and so what we do is we add or subtract the numerators and then just copy over that common denominator. And then finally we simplify. Because remember, especially with these rational expressions, there may be some simplification that can be hidden in the background there. So we need to do that final. We need to do that final step if necessary. Okay, so four-step method: determine the LCD, rewrite them, do the addition, subtraction, and simplify. Let's go back to our original problem here and apply those 4 steps. Well, let's see. The first thing I'm going to do with this set of expressions here is I'm going to factor each one of the denominators. Here, let's just write them out like this. The first one, I notice that the factorization of that, I'm just going to pull out an x out front, and I'm left with 3x plus 2 minus my 3x in the numerator. And then now this one here, 12x plus 8, turns out that I can pull a 4 out front, and isn't that interesting? I get a 3x plus 2 again. Okay, so now, can you recognize what's needed? What I'm going to have to do is I'm going to have to take this this x term, I'm going to have to take this factor, and I'm going to have to take the 4. I don't have to take the 3x plus 2 again because it's already represented over here. So the 4 times the x times the 3x plus 2 is going to be my new common denominator. In order to get that common denominator, I need to take this fraction and introduce a factor of 4 in the denominator, don't I? So I'm going to multiply that by 4. Well, if I do that in the denominator, I have to do that in the numerator. What do I need to do over here? Well, I've already got the 4, the 3x plus 2, but I don't have an x. So I need to multiply by an x. Do that in both the numerator and denominator, and let's see what we get in our final result. Let's see, 4 times 4 is 16, and this fraction is going to end up being 4x, 3x plus 2 in the denominator, minus, let's see, 3x times x is 3x squared, okay, divided by, again, 4x, 3x plus 2. All right, now, what I've done is I've rewritten each one of these original rational expressions as an equivalent rational expression, but now they both have the same denominator. Now I can do the subtraction. Now how do I do that subtraction? Well, I just simply write down 16 minus 3x squared. That is, I subtract the numerators and divide 4x, 3x plus 2. Okay. Finally, I'm going to take a look and see if I can reduce this any farther, if I can simplify it any farther. But I'm looking at this numerator, and I'm not seeing anything that I can that I can simplify any farther here. So let's call this thing is done. No simplification is possible there. So let's review. What did I do in this particular example? Follow those 4 steps. Okay. I took the original rational expressions and determine the LCD. In this particular case, we determined there were 3 factors in the LCD. I rewrote each expression as equivalent with the LCD, do the add subtract, and then check to see if there's any simplification. And that's how you do these.